at a new piece of learning called the cosine rule. So that will be the new stuff today. But before I do that new stuff, I might just take a look at maybe one or two of the questions we did for homework last night. So I think I gave you 4, 5, and 7, was it? I think I did 6 and 8 yesterday. So if I do question 7 now myself, that should have been the hardest one you had for last night, okay? So let's take a look at that. So no one asked me to do any questions, so I'll just take a chance that question 7 might be worthwhile doing. Maybe I just might draw this triangle first of all. That's 52, that's 73, that's 31.5. So I'm not interested in drawing lighthouses here, okay? P, Q, or, and the first question is find P or Q. So the way that notation works is that you start at the first letter. So we're going to start at P. We're asked to find P or Q. So we then go P, we then go up to or, and then back down to Q. So we're talking about this angle up here. So we're talking about this angle up here. That's the angle we're looking for. Let's call him theta. Now, it makes sense whenever we're doing these type of questions to label up our triangle. So I'm going to use the sine rule because I'm dealing with opposites. So I'm going to go A over sine A is equal to B over sine B. So therefore, in my diagram, I need an A, a big A, a small b, and a big B. So let's call this 31.5, let's call him big A. That means the 52 is going to be the small a because he's the side opposite. Let's call theta big B, and let's call the 73 the small b. So that's pretty good. I can now set up my formula. I can say that 52 over sine 31.5 equals 73 over sine of theta. So I now have one fraction equaling one fraction. So maybe the first thing to do is to get rid of that sine 31.5 because we can definitely put that into our calculator. So that's 0.522. Okay, now I have one fraction equaling one fraction, so I'm now allowed to cross multiply. So I have 52 sine theta equals 73 times 0.522. $38.14, and that's equal to 52 sine theta. So sine theta by itself must equal to 38.14 divided by 52. So that's equal to 0.734 sine theta. So theta by itself must equal sine inverse of 0.734. So theta must equal 47.18 degrees. So I've worked out what theta is there, or I've worked out what P or Q is. Then it asks me to find P or. So I can now fill in 47.18 into my diagram. So the diagram now looks like this. That's 31.5. That's 47.18. And that is unknown. This is 52, and this is 73. Now, we're then asked to find the length of this side over here. So I'm going to call this the side C. So we're asked to find the length of side C. Find the distance PR. Now, if that's the side small c, well then that must be big C. And we can call this angle up here big A, and we can call that small a. We can call that big B, we can call that small b. So I can now set up my formula where I can say A over sine A equals B over sine B equals C over sine C. So I can say 73 over sine 47.18 equals, so I'm going to get rid of this guy here because we don't really need him anymore, because all we need is the thing with C's in it. So I'm going to put that as a C all over sine of big C. Now, big C here, we can work that out because this angle and this angle and this angle must add up to 180. So 47.18 plus 31.5 plus big C all must add up to 180 degrees. So big C must therefore equal to 180 minus 31.5 minus 47.18, which is equal to 101.32 degrees. So my big C is actually equal to 101.32. So I then come along and I turn my sine, cos, and tan, all that sort of stuff, into numbers. Sine of answer. So I get 0.9805 there, and I get 47.18 equals 0.73 35. So again, I have one fraction equaling one fraction. I'm allowed to cross multiply. So that gives me 73 multiplied by 0.9805 is equal to 0.7335C. 73 multiplied by 0.9805 equals 71.5765 equals 0.7335C. So C must equal 71.5765 all over 0.7335. So C must equal to 97.58, and that's going to be meters. Oh, corrected nearest kilometer. Let's call it 98 kilometers. Yep. So that's how we use the sine rule. Okay. Now the sine rule is all to do with opposites. So if your triangle is set up where you have an angle and a side opposite it, and you have another angle and you're looking for a side opposite that, well, that's probably going to be the sine rule. The cosine rule, on the other hand, is a little bit different. The cosine rule also works for non-right angle triangles. But between the sine rule and the cosine rule, you can basically do everything you will ever need. So the cosine rule is, if we have this triangle here, I call this A, and I call this B, and I call this C. Well, we know that that's the side small c, that's the side small a, that's the side small b. We know that. That's normal. That's the way things are, okay? If I'm looking for something, okay, some side or something, I can use the following formula, and the following formula is on page 16 of maths tables. And the formula tells us that in this triangle up here, we know that a squared equals b squared plus c squared minus 2bc cos of a, or the cosine of a. Now, that's a really important identity, okay? And it really comes down to, do you know how to label up a triangle? So let's take a look at an example. So we might go through the example in the book. Will that be sensible? No, we'll go through page 411, question 1. Right, so let me maybe just draw this triangle. We have 7, we have 6, we have A, we have 39 degrees. Yep. Okay, so we spot that we have the normal setup for the cosine rule, where we have an angle trapped in between two known sides and we're looking for the side across from it. So I basically highlight the entire triangle there, okay? But it's an angle trapped in between two known sides. When you have that set up, the cosine rule is generally the way to go. So we need to label up our diagram. So the only angle in the formula is that big A, so that has to be the known angle. We have to call that big A. That automatically means the side across from big A is small a. Even if that letter there happened to be an X or a Y, we would still call it small a. This 7 here, doesn't really matter what we call that. We can call that B, we can call that C. Doesn't really matter. If we call it that way, then it doesn't really matter again, but that's big B and that's big C. So we then throw the information into our formula. So a squared equals 7 squared plus 6 squared minus 2 times 7 times 6 times the cosine of 39. So a squared equals 7 squared plus 6 squared minus 2 times 7 times 6 times the cos of 39, which is equal to 19.7197. So a squared equals, sorry, it doesn't, that's wrong. So A is equal to the square root of 19.7197. So A is equal to 4.44. So that's the size of A. So that's how we use the cosine rule, okay? So it's basically using all of these letters in a formula. So once you are able to label up a triangle, you're doing fine, okay? So tonight for homework, I'm going to assign page 411, question 1, part 2, and part 3. Okay, guys, so I will actually see you in class tomorrow. We will hold a live lesson on Friday. So until then, stay safe.